Good afternoon and welcome to our lesson once again. We are still on light and we are discussing light as one of examples that we are going to look at as a wave. Now, we went as far as rectilinear propagation of light, where we discovered that actually light travels in a straight line, and we were able to appreciate that when we obscure the path of light, there we form a shadow. Now, we went even as far as looking at the factors that will contribute to the different types of shadows that we can form, where we discussed the size of the obstacle. You could talk about the size of the source of light, or here you could even talk about the nature of the source of light, and you can also talk about the distance of the source of light from the obstacle. Now, we want to look at eclipse as one of the natural shadows. Eclipse as one of the natural shadows that occurs within the solar system. And we are going to define eclipse as the total or partial disappearance of the sun or the moon as seen from the earth. It is actually the total or partial disappearance of either the sun or the moon, and that one is as seen from the surface of the earth. Remember that an observer who is interested in the behavior of the solar system can only observe from the earth's the surface of the earth, and therefore from the earth you will not see the sun or the moon when the three come into are in a straight line, because we appreciate that the sun, which is taken to be the center of the solar system, is always still, but the earth and the moon are always in constant motion around the sun. Now, the path of the earth and that of the moon are not equal. That of the moon is much smaller compared to that of the earth. However, the orbits are always around the sun, much as we say that of the moon is actually elliptical, which means it's not actually a perfect circle. It's a sphere around the sun. There are some points, there are some diameters that will be bigger than others, and therefore we appreciate that fact when it comes to the types of solar eclipse that we can have at our disposal. Now, we can only be able to discuss an eclipse in relation to the relative position of the three bodies of the solar system that eclipse can only be fully described relative to the position of the ring. Here we are talking about the sun, we are talking about the moon and the earth. Depending on the position of each one of them, we will have different types of eclipse, as we are going to discover in a bit. Probably we start by looking at types of eclipse, and here we are going to look at 3. We have the solar, the lunar, and the annular. The solar, the lunar, and the annular eclipse. The solar and the annular are actually eclipses of the sun. Eclipses of the sun. And if they be eclipses of the sun, then why should we discuss 2 of them? We are going to discover in a bit. Let us start by discussing the solar eclipse. Solar eclipse. And this one, we have said in itself, is a form of eclipse of the sun and is formed when the moon passes between the sun and the earth. When the moon passes between the sun and the earth, so some part of the sun is obscured. Some part of the sun is actually obscured, and therefore you cannot see it when you stand on the earth. That is why we call it eclipse of the sun, because what happens is that some part of the sun is what is not observed. Some part of the sun is what is not observed by someone standing on the surface of the earth. Now, the moon casts a shadow on the surface of the earth. The moon will actually cast a shadow on the surface of the earth. Now, if we would represent that as a form of a diagram, we have the sun here. This is the sun. Then we are saying we have the moon somewhere. Then we have the earth at the far end. Then we have some rays of light. We have some rays of light. We have some rays of light which come to the surface of the earth from the sun. On the far end, you also have some rays coming to the surface. You will discover that at some point, there will be a space in between. If this be the moon, this is the earth, then you have some rays coming from the sun. Remember, the sun is the sole producer of the light that we are talking about here. And now on the path of the ray of light, this one is what is going to act as the obstacle. Now the whole of this point will be a shadow of the moon. This is the shadow of the moon. And this one is to mean that there is some part of the earth that is actually not seen when you observe it from the surface of the earth. This one is an example of solar eclipse. Remember that the shadow is actually an umbra, meaning that it is actually totally dark, and it's also uniform, totally dark as well as uniform. Now, then, if this is a solar eclipse, then why should we say that annular eclipse is also? Why should we say that annular eclipse is also a form of solar eclipse? Now, there are times when the moon is very far from the earth. There are times when the moon is very far from the earth, and we say this is courtesy of its orbit, which is elliptical. Courtesy of the orbit, which is elliptical, you discover that there are some points at which the moon will actually be very far from the sun. And when that be the case, you will have the solar eclipse, where this one is the sun. Then you will have some moon, and then it's very close to the earth. Remember that the orbit is actually elliptical, and therefore at some point, if the sun is here, the moon, this is the sun, the moon is following this orbit round and around. It will reach a point when it will be there, and the ellipse is actually going to give it a chance to be as far as possible from the surface of the sun. And when that be the case, then you will discover that some light from the sun is going to spill over some light from the sun is going to spill over and get to illuminate the shadow. Is going to spill over. It will actually illuminate the shadow, so that now you will form a completely dark part. You will form a completely dark part surrounded by a penumbra. Surrounded by a penumbra. These ones are shadows, but now you have lighter parts, and that one is an example of an annular eclipse, which is a combination of an annular and a penumbra. This is the moon, and then you have an umbra, and this one is surrounded by a penumbra. This one is an example of a lunar eclipse, which is actually a solar kind of eclipse, only that it has an umbra surrounded by a penumbra. In both situations, we have seen that the moon is actually passing in between. It's obscuring light from the sun from reaching the earth. That's casting a shadow on the surface of the earth. And now we have the two patches, one which is dark and the other one which is a bit light, a phenomenon we called a penumbra. Now to the third and the last one, which we call the lunar eclipse. The lunar eclipse, or we can call it the eclipse of the moon. The lunar eclipse is also called the eclipse of the moon. And now we ask ourselves, what is happening in the formation of the eclipse of the moon? Now here, the earth passes between the sun and the moon. So we have them on a straight line, yet again, only that now this time the earth is the one at the center. Then we have the moon at the far end. The moon at the far end. Therefore, some light from the sun is actually obscured from reaching the moon. Some light is actually obscured from reaching the moon. And when that be the case, when that happens, we expect the earth to cast a shadow. We expect the earth to cast a shadow on the surface of the moon. We expect the earth to cast a shadow on the surface of the moon. Sometimes the moon is hidden completely and you cannot see it when you observe it from the surface of the earth. And now you have a total you have a total shadow, and the moon is completely hidden, and that way we claim that lunar eclipse has happened. So here we have total umbra, courtesy of the earth, going between the sun and the moon. We have total umbra, courtesy of that. However, it is worth noting that here the earth casts a total shadow on the moon. You have a total shadow that is cast by the earth on the moon. Therefore, when we talk about the solar eclipse or the eclipse of the sun, it's part of the sun that is not observed if you look at it from a point on the earth. And then if we talk about lunar eclipse, the moon is hidden. So an observer on the surface of the earth will not be able to see the moon if you observe it from the earth. That is why we call it lunar. Yes, so now you are able to discover that eclipses actually derive their name. They derive their name from what is hidden. From what is hidden from an observer. What is hidden from an observer? If you hide the moon, we call it lunar. If you hide the earth, we call it solar. Now, that's one of the phenomena that we can actually discuss. The formation of shadows, which comes courtesy of light being having that property that it travels in a straight line. Now we go to something else we are going to call reflection. This is the second property that we are going to appreciate with reference to light. And what is reflection? Reflection is actually bouncing back. Bouncing off, or we can call it bouncing back of light. Now we were able to explain light in terms or from the point of view of a wave, and we discovered that light is actually a transverse wave comprising of crests and troughs. It's comprised of crests and troughs, and when it comes to a fixed end, when it hits a fixed end, when light hits a fixed end, what happens is that it's going to be reflected. Let us say our fixed end is at that point. And once light is reflected in form of a wave, it superimposes itself on the first wave, a result of which we said is actually a stationary wave. And a stationary wave, again, we said is characterized by nodes and antinodes, where these ones, the nodes, are areas of zero displacement, and antinodes areas of maximum displacement. Nodes and antinodes, where nodes are areas of zero displacement, antinodes are areas of maximum displacement. Now, when that happens, we claim that light has been reflected. Can we benefit from the reflection of light? Now, the question is, are we observing a luminous or an unluminous material? Because if we are observing a luminous material, it actually produces its own light. That is to mean you do not need the help of reflection for you to observe it. But when you are observing an unluminous material, light from a source has to come, fall on the object. It reflects the light to your eye and you are able to see. Therefore, reflection helps to observe what we call non-luminous an unluminous material is just a material that cannot produce its own light by, or we can say when light from a source bounces into our eyes when it falls on them. So, if you had a source of light here, say a candle, then you have if you had a source of light, say a candle, then you want to observe a piece of wood. At that point, you will have some rays coming to your piece of wood. The rays bounces back into your eye from the source, and that way you will be able to observe. So this one is a candle, which in our case is the source of light. Which is luminous, produces some light into the wood, which is non-luminous, and in this case it acts as our reflector. Then you will have reflected rays into your eye, and that way you can be able to observe that. Now, the amount of light reflected depends on the nature of the surface. And here we are talking about the surface of the reflector or the reflecting surface. What do we mean? We mean how rough or smooth is the reflecting surface. How rough or smooth is the reflecting surface. Now, depending on how rough or smooth the reflecting surface is, we could have these types of reflections. We could have these types of reflection. One, we have what we call regular or specular. Regular or specular reflection. What kind of reflection is regular or specular? This one is where a parallel beam is reflected in only one direction. A parallel beam is only reflected in one direction, and this one is courtesy of a smooth reflecting surface. That you will have a parallel beam from a source fall onto a smooth surface and is reflected in only one direction, in such that the incident and the reflected beam appear to be similar but only different in direction. Like we can look at a plane surface, say a mirror, which is an example of a polished surface. And we have a parallel beam incident on the same parallel beam from a source incident on our polished surface. Remember, we said the direction is very important, as well as the size of the arrows. That one will give us the intensity. These ones are going to be reflected in such a way that they are also parallel. The only thing that differs is the direction of motion. However, you have an incident beam which is parallel, and then the reflected beam is also parallel, courtesy of a polished surface. A polished surface is actually very smooth. Now we shall have this one as the reflected beam. This is the reflected beam. And the other one is actually the incident. The incident beam. Incident beam. And the incident is the one from the source. We call it the incident beam because it is traveling from the source to the reflecting surface. The reflected beam travels away from the point of reflection, which is actually a smooth surface. Now we want to give examples of materials that would give us regular reflection. We have one is a white sheet of paper. White sheet of paper. We could talk of silvered metal surface. And lastly, we could talk of a mirror. Just a plain mirror. The three are examples of materials that would give us smooth or regular reflection. Regular reflection. Remember we said the fraction of light incident onto a surface. What determines the fraction of light that is going to be reflected is actually the nature of the material, and where the nature means smoothness or roughness. Now this one was a smooth surface. Now that one gave us the first type of reflection. Number two is what we call the irregular or diffuse reflection. Irregular or diffuse reflection. What type of reflection is that? This one is where parallel beams, beam from a source scatters in many directions. Scatters in many directions when it falls onto a rough surface. We have a beam of light that is very parallel. It is incident on a rough surface and is reflected, so that now the beam that is reflected actually spreads out to different directions. Now, let us take an example of this surface. This is a surface that is very rough. We'll let a parallel beam to be incident onto it, a parallel beam. Now, we are not guaranteed of the direction after reflection. If you had another ray incident, it could even be scattered the more, and that is why we say it is actually irregular, because you don't know what to make of the reflected beam. You don't have the name to call it now that rays are scattered in different directions. So this one is a rough surface. This one is incident beam. And like you can see, the reflected rays are in different directions, so you cannot actually collect them to form a beam. We can look at examples of such examples of materials that will give us irregular, or what we call the diffuse kind of a reflection. We could talk of a piece of wood. A piece of wood is an example. You can talk of a manila paper. You can talk about concrete. You can talk about plastics. And the list can continue. You can talk about such. Now, we want to look at reflection by plane mirrors. We want to look at reflection by plane mirrors, and we said a plane mirror is an example of a material that will give us regular reflection. And find out, there are some terms we expect to use here which we need to define, and I will start by defining them. Here, number one, you can talk of incident ray. What is an incident ray? Now, this one is a ray traveling from the source. From the source of light. Here, you could have a luminous source of light, and then you have a ray to consider, which is actually traveling from the source. That is what you could call an incident ray. Now, you could also talk about reflected ray, which again is a ray from the reflecting surface. A ray from the reflecting surface. That is what you call a reflected ray. Then you could talk about the normal. And this is a line drawn perpendicular to the reflector at the point of incidence. At the point of incidence, you could come up with a line which is perpendicular to the reflecting surface at the point where the incident ray actually strikes the reflector, and that is what you call a normal. That is what you call a normal. Another term that we need to look at is the angle of incidence. Angle of incidence. And this one is the angle between the normal and the incident ray. Angle between the normal and the incident ray is what we call the angle of incidence. Sometimes we use capital R and small I to represent it. Now we could also talk about the last term, which is angle of reflection. Angle of reflection, which is the angle between normal and a reflected ray. That is the angle between the normal and the reflected ray. Sometimes we use small r to represent the same. Sometimes we use small r to represent the same. We can represent those terms diagrammatically. You can represent those terms diagrammatically. You can represent that using a diagram where you can have a smooth reflecting surface. Oh, look. Smooth reflecting surface. Then you can have an incident ray from a source. You have a normal perpendicular at that point, and this ray is actually reflected so that it has the same angle. This is the angle of incidence, the angle of reflection. This one is the incident ray. This is the reflected ray. We have the normal. So again, very fast we can go through our terms. That incident ray is that ray that travels from the source to a point on a reflecting surface. At that point of incidence, you can be able to draw a normal, which is actually perpendicular to the reflecting surface at the point of incidence. You could also have your ray reflected from the same point where there is the normal, forming an angle R. Now, angle I is what we call the angle of incidence, which is the angle between the incident ray and the normal. The angle of refraction is between normal and the reflected ray. Those are the terms that we are going to interact with in the course of our study on reflection. Therefore, we are saying that a plane mirror is actually an example of a smooth surface. Let us say, for example, we had a bench, then on it we place a plane mirror, so that now we have a beam of light parallel and from a distant source coming to the surface of our mirror, we expect that is going to be reflected so that we have another parallel beam, but the only difference will now be the direction. So this one is our plane mirror, an example of a smooth surface. Then we have incident beam, and we have the reflected beam. We have the incident and we have the reflected. Beam. An example of smooth kind of a reflection. An example of a smooth kind of reflection. Now, with that, we come to the laws of reflection. Laws of reflection, and these ones are actually derived from reflection on a smooth surface. And like we have seen from the terms, we have a smooth surface, we can have an incident ray, a normal, and a reflected ray. Are actually derived from our reflection by a smooth surface. If this be a smooth surface, we have seen the angle of incidence, the angle of reflection, and then this is the incident ray. This one is the reflected ray. Now, from this diagram that we have here, we can observe, number one, that at the point of incidence, all rays lie on the same plane. At the point of incidence. Now, when we talk about all rays, we talk about the incident, the normal, and the reflected. At the point of incidence, all of them are on the same plane, which is now our reflecting surface. That is what we mean by that. Number two, we can discover that I is equal to R, where I is actually the angle of incidence and R is actually the angle of reflection. Those are things we can observe from our diagram here, where the angle between the incident and the normal rays is what we call the angle of incidence, and the angle of reflection is between the normal and the reflected. Please do not confuse these ones for these other angles. These other angles, we are going to discuss them at a point later, But only here the angles we're interested in are these ones, the angle between the incidence and the normal. Then we have the angle of reflection between the normal and the reflected ray, and those ones are equal. For there to be a regular reflection, the two have to be equal, and again the three rays involved must all lie on a straight line. And it is worth noting that those ones, the two statements, these comprise of laws of reflection, they comprise of what we call the laws of reflection, and they hold for all. They hold for all reflecting surfaces. They actually hold for all reflecting surfaces. Having looked at types of reflection, we have looked at the laws of reflection. Now we can advance to image formation. Image formation by plane mirrors. Image formation by plane mirrors. And we can start by defining a plane mirror. And a plane mirror is actually a flat, smooth. It's a flat, smooth, reflecting surface that forms images by regular It's worth noting that it's actually a smooth surface, and that is why we say it forms images by regular reflection. It forms images by regular reflection. Now, in general, images formed by plane mirrors are actually virtual. They are virtual because mirrors form images by extending reflected rays. Rays do not actually meet to form an image. Rather, they appear to meet to form an image. And for that reason, we say that images formed by plane mirrors are actually virtual. Virtual means that the image cannot be formed on a screen. The image can actually not be formed on a screen. Therefore, we need to note that a plane mirror is actually smooth. For that reason, any result that comes from a plane mirror has to be as a result of regular reflection of this wave that we are calling light. Though, after reflection, the rays do not meet. They only appear to come from a certain point. And for that reason, we take the images to be virtual. Now, next time we meet, we are going to look at characteristics of images formed by plane mirrors. There are quite a number. We shall draw them so that we can see why we claim that the characteristics hold. Thank you.